Alright, next up we've got a tougher example. I say it's tougher because some people might look at this and think that their inner layer, or the u they should have, should be an x, because hey look, it's inside both of the trigonometric functions. But in this case, since it's inside 2, that's not going to work very well. Actually, part of the thing that'll let you know if U-substitution will work for an integration is whether or not what you're integrating will get you something that is also the same as another part of the function. Because since we've got a sine here and a cosine there, both of those are going to integrate to different things, and it's not going to help us very well. What would be a lot easier, however, is if we were to make this sine here our u, because, as you should know, a sine, like the derivative of a sine, is equal to the cosine. So that would allow us to much more easily come up with a substitution that will give us a very simple thing to integrate. So so we set our u equal to the sine of x, ignoring the exponent, of course, and then the du then, of course, is going to then be the cosine of x times dx. Then now, with that, just that alone, now we can like make this whole long thing look much less scary, and set that to, we don't even need to bring any constants at the outside, because now we just have it as u to the power of 3 du, which can easily be made down to u to the power of 4 over 4 using the most basic of all integration rules. And subbing that back in, we can have, subbing the u back in, it'll then give us the sine of x to the power of 4 over 4 plus c. Now, next up, we've got a definite integral, as you'll see from the bounds. Now, in this case, it's really not actually that much different, because the first step, the most important step, is still always just the basic. You'll still have to do a basic indefinite integral first. The only real difference is that if you remember your fundamental theorem of calculus, really all you need to do once you get the indefinite integral is to then just simply subtract the upper bound from the lower bound for that for that value. So I'm finding the indefinite integral right now. You should be able to do that at this point. There's really not much you haven't seen before. But now we can do, to get our answer for the definite integral between that bounds, is then plug in the upper bound into this value of calculated, ignoring the plus c actually, and then subtracting the same thing for the value of 0, for the lower bound. So at this point, honestly, we can pretty much do it in our heads. So if we're plugging in 1 for x here, then it's 1 squared, it's going to be 1. So it's going to be half of the ln of 2. So that's going to be ln of 2 over 2 minus, so then we're going to subtract whatever they did for the lower bound. So 0 to the 0 squared is just 0. So now it's half the ln of 1. But as everyone knows, the ln of 1 is already a 0. So you're just subtracting 0, meaning the answer to the definite integral for this is just ln of 2 over 2. It's as simple as that. Now let's do it for the last 3 just to finish this up. So once again, we're finding a u. It might be a little bit trickier in the case of fractions because sometimes it's not always immediately clear which thing you'll have to make your u. But just remember to look out for whichever part of the fraction that, when derived, will give you something that looks like another part. This is actually a little bit tricky in general, but do our substitution where we once we do our integration, where we increase the exponent by 1 and divide it by that level, then we'll have like 1/2 over, it just subs down to the 1 over u. Okay, yeah, so our indefinite integral here is going to be -1 times 2 over 1 plus x squared. Then there would usually be a plus c here. But now let's plug in our bounds. So if x were equal to 2 here, then this is going to be 2 times 5. So this would then be a -1 over 10 minus, and then let's see what that would be for the 0. Then it's going to be 1, 2 times 1, it's going to be negative, it's going to be -1 over 2, and the negatives cancel out, so we're adding. So this is going to get us 2 over 5 as our definite integral, a definite value there. Alright, almost done here. This one actually, honestly, this one you could pretty much do in your head, but let me show you how to do it anyway, using this method. So once again, at this point, it should be getting pretty obvious what the u's are. In this case, you know it's not going to be just the 2, because that on its own is the constant. You wouldn't need to do a chain rule or a substitution, whether you're differentiating or integrating, either way. So we know, or you can tell right away that our u is just going to be that. Our u is going to be the x squared, which means our du is going to be, or the half of our du anyway, which is going to be the x of the dx. And bringing out the constant that was already there to the outside. Now we can see that those are just going to cancel out anyway. So let's integrate that to get just e to the u, because that's a very simple thing to integrate, or e to the x to the 2. And now don't forget to do our definite integral. So plugging in a 2 for this is going to, be e to the 4, and now plugging in a 1 for this, well, 1 to the power of 2 is still 1, so now it's just e to the 1, it's just e. Another very simple thing there. And now for our final problem, question 10. This one might look a little scary, but I assure you, it's not too bad. Since we can see that the derivative of t plus 2 is going to be equal to 1, we can simply deduce that that's going to be what that'll be. So the du then is going to be just 1 dx. So our indefinite integrals is going to be the 1 over u du, and which derives down, or integrates down to the ln of u, or the ln of t plus 2. So now plugging in e minus 2 for this, the 2's are going to cancel out, so just the ln of the e, which is, yeah, the ln of e is just going to be 1. So that's going to be 1 minus, now plugging in the -1 for this, then the -1 plus 2 is just going to get you 1, so it's just going to be 0. So our definite integral for number 10 is going to be 2. Make sure you understand all these examples pretty well. Make sure you understand these as best as you can. Feel free to ask questions to me in person or in the comments below, I suppose, to help yourself get a better understanding for all of these. If you don't have an airtight understanding of all this already, this stuff is pretty important to know. You're gonna find it very useful in all the upcoming quizzes and such. But yeah, I hope that helped at least somewhat. Toodles.